volume of cones. On Tuesday we talked about the volume of a cylinder. Today we're talking about the volume of a cone. And tomorrow we'll talk about the volume of, I think, a sphere. I think that's what's next. We'll see. So, cones, they look something like this little guy here. Now, let's think about this in the real world, right? Where have we seen a cone in the real world that looks like this? Ice cream cone, good. Ice cream cones definitely look like this, more like waffle cones, right? Not really the cake cones. A party hat, beautiful. That's right, Dylan. Exactly. Party hats are nice, perfect cones. Where else have we seen a cone?
A snow cone.
Yes, there we go. A snow cone. This looks just like the little, waxy paper cups that hold snow cones. Excellent. So cones, again, are all around us. Most of the time we see them as party hats or snow cone holders, like we said. So something interesting about cones as it relates to our last lesson is this note here. The volume of a cone is exactly 1/3 the volume of a cylinder that has the same base and the same height. Okay, I'm going to read that again. The volume of a cone is 1/3 the volume of a cylinder with the same base and height. We'll explore that a little bit more in term 4, I believe. But can I get a volunteer here to read this first definition up at the top? Go ahead, Alexa. Exactly, and that is our diameter. Everybody say diameter.
Diameter.
Have we heard this term before, folks?
Yeah.
I sure hope you have, because you definitely talk about it in 7th grade. So the diameter is very, very similar to the radius. The difference is, though, that the diameter covers the entire length of the circle. Let me show you what I mean. If we have a circle here, there's our center, right? The diameter covers from one edge to the next edge, but it has to go through the center of the circle. That's the key. Right? Whereas a radius, it still goes through the center, but it's only 1/2 of the distance of that circle, right? So there's D, and that one is R. Radius versus diameter. Now you may notice that in our formula today, we're still using R. So why are we talking about diameter? Well, let's take a look down at this first cone here. Well, the only cone that we have. Can someone tell me what's the height of this cone? 6 kilometers. Exactly. That's the height of our cone. 6 kilometers. Straight down the middle of our cone gives us a height of 6. Now, what's the radius of this cone? 3, exactly. Thank you. 3. Now, you may be thinking, well, there's an arrow pointing right to it that says 6. This is why I brought up diameter. Because the diameter all the way across the circle, that is what is 6. That's a weird way of saying that, but you know what I mean. The diameter is 6. The diameter equals 6. So the radius then is half of that 6, which is equal to what? 3, just like we said. Our radius is 3 kilometers. Give me a thumbs up if you're all good on diameter versus radius. Like, in terms of, I know how to recognize which one is which on a diagram. Okay. Because on a worksheet 63, we only were given the radius. But on our worksheet 64 today, some problems we're going to be given the radius, some we're going to be given the diameter. So you have to make sure if the diameter is listed, you first have to cut it in half before you plug that number in for R. Let's go ahead and plug these numbers in then. Our formula is V equals 1/3 pi r squared h. I'm going to bring up Tuesday's formula. Here it is. So here's the volume of a cylinder. Here's the volume of a cone. What's the difference between those two? Is there any difference at all between those two formulas, Noah?
The fraction.
The fraction, exactly. There's a 1/3 in front. But the rest of our formula is exactly the same. Okay, so that makes it, ironically, easier to memorize because they're the same. But it's also easier to mix them up because they're so similar, right? So we always just have to think about this. The volume of a cone is just 1/3, that's where this 1/3 comes from, of the volume of a cylinder with the same base and height. So, let's go ahead and plug these in and get started. 1/3 pi r squared, what was my r again? 3 times h, what's my h? 6, exactly. We're going to start this process out exactly the same as we did on Tuesday. 3 squared is just 3 times 3. So what's that going to give us? 9, right? 3 squared is going to give us 9. And we've got v equals 1/3 times pi times 9 times 6. What should we do next? Someone help me out. Yeah, what are we going to multiply? Perfect, let's do it. 9 times 6, what's that going to give us? 54, good, 54 times pi times 1/3 equals v. Now what? What can we do next? Heard someone say fraction. What are we going to do with that fraction? We're going to multiply it, exactly. We're going to multiply it by 54. I'll do a little aside here. 54 times 1/3, right, is the same as saying 54 divided by 3. Right? So what is 54 divided by 3? Close, very close.
18.
It's going to be 16.
I guess.
That's all right. That was a good guess. 16 times 3 gives us 54. So our answer here is v equals 16 pi. What are my units?
Kilometers cubed.
Kilometers cubed. Exactly.
54 divided by 3 is 18.
Is it 18?
Yeah, it's 18.
Oh, you're right. My bad. That was a good guess. Thank you for double checking that. I appreciate it. 18 pi kilometers cubed. Oh yeah, you're right. 3 times 16 would be like 48. So that's how we get 18 pi kilometers cubed. So now there's kind of another way that we can think about this formula if it's helpful. Because sometimes multiplying by a fraction can kind of confuse us. So we can also think about this formula like this. V equals pi r squared h over 3. Right? So you can plug in r and h, multiply those out, and then you have a nice fraction that you could just divide downward and get your answer. So if that makes more sense to you, if that helps you out, we'll go ahead and use this formula once we get our worksheet. But you're more than welcome to do it that way as well. I'm fine with either. So I know that was kind of short, but what questions can I answer about this? I doubt there's going to be any because we all, for the most part, had our thumbs up talking about the previous lesson, and this one is almost exactly the same. So